Hello everyone, hope you're having a great day. In this video, I'm going to show you how to create a simple gear train which has 3 or more gears. So I have used my gear template to create two gears which have different number of teeth. So to generate a gear ratio which is not equals to 1. So here you can see the one gear which have 32 number of teeth, module of 3 mm and the pressure angle of 20 degree. As you already know that the two meshing gears should have equal value of module and an equal value of pressure angle. So I have already designed or made another gear which have different number of teeth, that is 16, and the same value of module 3 mm and pressure angle of 20 degree. Also, to assemble these two gears, I have also created a bridge, which is basically a plate which have pins over it at a center distance equals to the sum of the pitch circle radius of these two gears. So let me just close these two windows and start the SMD design. Importing the first component, which is the bridge. That's taking quite a while. Okay, here's the bridge. As you can see, these pins will be helping us to assemble the gears. The second component will be this pinion. Just use manipulation toolbar to move it at the front. We're going to use another copy of this gear so that we can make a gear train which have 3 gears. Importing the other gear which have number of teeth equals to 32, automatically rename it. We just don't require specific name for it. Move it in front too also. Okay, so to add constraints, or you need to snap these gears to these respective pins. So double click on coincident constraint. First we'll start with the smaller one at the left side, the smaller one at the right side, and the middle one at the middle. Alright, the next thing what we're going to do is to use offset constraint so that we can have a proper mesh. So just select the surfaces and offset it at 10 mm. Okay, this gear also at 10 mm, and the leftmost 10 mm. So now that we have assembled these gears, we are going to observe that these gears might cause interference, which they are right here and right here. So just hide the bridge and use the manipulation toolbar. Select drag around any axis, select the axis of the larger gear, go to front view and position the larger gear such that you can see there is no interference between the gears of the pinion and the gear. Click OK, zoom out. Now that we can't see any interference on either side of the gear, so it's time to go switch to our DMU Kinematics. So start DMU Kinematics. First we are going to create a mechanism. For that, just click to fixed part, new mechanism, change this name to gears and select the fixed part, that is the bridge. Next up will be the creation of revolute joint. So click on revolute joint. First revolute joint will be the left side. We are going to start from the left, so gear 1, gear 2 and gear 3. So this will be the revolute 1, 2 and 3. Click on axis, hide the bridge, click on axis of the whole surface and the surface of the pin. Offset of 10 mm which we have given in previous step. Click OK. Just hide the constraints. The next revolute joint will be the gear number 2. hide. Just repeat the step again, offset, and you must not check the angle driven option. Click OK. Another revolute joint for the gear number 3. We are going to do the same, offset, OK. So now that we have created 3 revolute joints, it's time to create a gear joint. Click on gear joint, and which it requires revolute joint. So go to application, mechanism, gears and joints. Click on revolute 1 and 2. Opposite, as both the gears should be able to rotate in opposite direction, and ratio is actually the gear ratio which we are going to enter is negative 0.5, as gear ratio is equals to number of teeth of driver gear over number of teeth of driven gear. So we are going to make the gear 1 as the driver and the gear 2 as the driven. Click OK. So the first gear joint has been created. The second will be the between the gear number 2 and 3. Go to gear joint. It requires 2 gear joints again, but we have revolute joint, but we have only 1 revolute joint remaining, so we are going to create another revolute joint for the gear number 2. So click on create. Just repeat the steps as usual, unhide, offset, OK. The gear revolute joint will be revolute joint 2 will be the revolute joint number 3 of number gear 3 opposite, and here the gear ratio will change to -2, which means in this case the driver gear is gear number 2 and the driven is gear number 3. Click on OK. Now we are going to give a command to this gear so that it can make these 2 gears rotate in the respective directions. So gear, you must check this angle driven for revolute 1. Revolute 1 is the revolute joint for gear 1. So click OK. You get the information the mechanism can be simulated. Collapse it and hide the bridge so that you can observe it more clearly. Go to simulation with commands and just play. As you can see, there seems to be no interference between the gear joints that we have created. So this is a simple gear train that have 3 gears. Now we are going to create a gear train which have 4 gears. So just delete these gear joints that we have created. Now go to SMD Design, unhide the part that we have hidden. Now add another one of this gear. Use manipulation tab to move it around so that we can use a coincident constraint at this gear. So double click. As you can see, we have no constraints again, so we have to create constraints that we have created earlier at same time. All right, hide. Okay, so we have created the constraints of a coincidence. The next step is to create offset constraints. So click on offset constraint and 10 mm. Negative 10 mm, sorry. Okay, that's perfect. Next up will be these gears. Okay, okay, and the last one is also okay. It's now time to go to DMU Kinematics and hide these constraints again and create a fixed part, new mechanism, name it gears, add this fixed part and create revolute joints. Just you have to repeat the same step that we have done before. So I'm going to do it very fast. Offset negative, just double click it so that you can use it again. Just make sure don't check angle driven, that will be fine. Offset, and you must check offset. If you click null offset, the position of the gears will be compromised, so you don't want that. Offset, okay, cancel. Now it's time to add gear joint for all the gears. So the first gear joint will be the between the gear 1 and 2. So joints revolute 1 2 opposite direction, and gear ratio is 0.5 as usual. Click OK. The second gear joint will be between gear 2 and 3. So gear joint, as the revolute joint of gear number 2 is already used in the gear joint first, so we are going to create a revolute joint for the gear number 2 again. Okay, offset, okay, and this will be the revolute joint 3. Opposite, the gear ratio in this case will be -2. Click OK. Another gear joint will be between gear number 3 and 4. So again we are going to create a gear joint, revolute joint for gear number 3, as it's already been used in gear joint number 2. So offset, okay, and the revolute joint 4. Opposite, gear ratio -0.5. Click OK. So now you're going to simulate the gear train which have 4 gears. Go to simulation with command, bring it right here, and on request, and play. As you can see, this is a gear train which have 4 gears of different number of teeth. So thanks for watching and have a nice day.